network part 2. So let's move on to the topic. The model that we discussed before in our previous video was the perceptron model. If you want to build a complicated system, then a single perceptron model, that is a single neural network, won't be enough to learn a complicated system. So we'll need a multiple perceptron model or a deep neural network. And fortunately, we can expand on the idea of a single perceptron to create a multi-layer perceptron, that is a basic artificial neural network. We can build a multi-layer perceptron model, that is we can feed the data of a perceptron model to another perceptron model to build a basic artificial neural network. And in this topic, we'll even introduce the idea of activation function. And the bigger question is, how do we actually build a neural network? We discussed about perceptron model in our previous video, but how do we actually build up a neural network? So to build a neural network of perceptrons, we can connect layers of perceptron using a multi-layer perceptron model. That is, if the output of one perceptron model is fed as an input of another perceptron model, then we can build a neural network. So here is an example of an artificial neural network, that is a multi-layer perceptron model. This is the input layer. The output of one perceptron is fed as an input of another perceptron to finally gain an output. So this is a multi-layer perceptron model. Now let's discuss it in brief. We can see here, this is the input layer where input 1, input 2, input 3 and input 4 are fed to the hidden layer. We can see here, this is the hidden layer where the input values are fed to be processed, and next the last one is the output layer where the processed data are then outputted. And now talking about the layers in this multi-layer perceptron model, the first layer is input layer, the second one is hidden layer, and the last one is output layer. And the much complex part of this multi-layer perceptron model is the hidden part layer, because in a multi-layer perceptron model we can have multiple hidden layers, so it can be very challenging to trace the input and output values undergoing the processes in the neural network. As stated below, neural network becomes a deep neural network if they contain more than one hidden layers. We can see here we have multiple hidden layers, that is one hidden layer, first hidden layer and the second hidden layer. If a perceptron model contains more than one hidden layer, then it is a deep neural network. We can see here, we discussed about a simple type of perceptron model in our previous video where we had only one input layer and one hidden layer and one output layer. So that perceptron model which we discussed before was a non-deep neural network. And if a neural network has more than one hidden layer, previously we had only one hidden layer, but here we can see we have multiple hidden layers, hidden layer 1, hidden layer 2 and hidden layer 3. So this is a deep neural network. So these are the properties how we identify between a deep and non-deep neural network. And the incredible thing about that neural network framework is that it can be used to approximate any continuous functions, okay? And also researchers did prove that mathematically neural networks can approximate any convex continuous function, and we'll be discussing about this in our further upcoming topics. As we discussed in the previous video, the mathematical representation of a perceptron model was like this. F of x was the processing function, x1 and x2 were the x1 and x2 were the input values, and y was the output, where we considered f of x as a simple summation function. So y was equal to x1 plus x2. And previously in our simple model we saw that the perceptron itself contained very simple simulation function f of x, as I said before. And for most use cases, however, that won't be useful. We'll want to be able to set constraints to our output values. That is, we want to manipulate our output values, especially in classification task, and we'll be discussing about classification task as well. So in a classification task, in general, it would be useful to us to have all the outputs fall between 0 and 1, and these values can then present probability assignment for each class. The values 0 and 1, the classification task output values 0s and 1 can represent probability assignment for each class. And yeah, thank you for watching the video, and we'll be talking about activation functions in our next video.